In 1988, James Hansen gave some groundbreaking testimony in front of Congress, where he said for the first time that the signal of human-caused global warming is discernible outside of the variability of climate.
Based on what we knew in 1988, Jim Hansen was out on a limb. You could have reached an alternative conclusion fairly. And in fact, if you look at the 1990 IPCC report, their attribution statement was that the system was warming, it was consistent with global warming, but it was also consistent with natural variability. He was kind of out on one end of how you could read the data, but it turned out he was right.
Our best estimates of natural climate variability can't come anywhere close to matching the size of the warming signal that we see, that we measure, that we've monitored. That seems like an important thing to state very clearly.
Amazing. I mean, Hansen has been remarkably prescient when it comes to the predictions he made decades ago and what's actually played out. He predicted essentially the warming that we've seen 3 decades ahead of schedule.
Well, Hansen got it right, basically, because by now there is no more doubt that we are observing this signal of global warming. It has really very clearly emerged from the natural variability in the climate system, and also the projections for the future that Hansen published at that time, they have turned out to be correct.
And so Hansen looked at 3 different scenarios. Scenario A that had very rapid increases in greenhouse gases and very rapid warming, a scenario B, which had much more modest increases, and a scenario C, which had essentially no increases in the future. And so now we can actually compare what's happened to what Jim Hansen projected. And so of all the scenarios that Jim Hansen produced, his scenario B is closest to what's actually happened.
And the warming that he predicted in that scenario is an eerie match to the warming that we've actually seen.
Back in 1981, Hansen had produced another paper where he had projected future temperatures, and those were quite close to what we've observed today, in fact, slightly too low.
Well, the actual temperature rise since my first major paper in 1981 has actually been faster than what we calculated then.
We did an exercise recently where we looked back at all the climate model projections that have been published since 1975. So there's a paper in 1975, in 1981, in 1988, in 1990, 1995, et cetera, that all had climate model projections for the next few decades. And we compared them to observations, both before they were created and after they were created. And it turns out they all match up remarkably well with what's actually happened.
Globally, we've seen warming of roughly 0.18 to 0.2 degrees Celsius per decade. So that's nearly 3/4 of a degree Celsius over the satellite era, global scale warming. And that dwarfs our best estimates of natural climate variability on that multi-decadal timescale.
He also successfully predicted the cooling that we would see once Mount Pinatubo erupted back in 1991.
He recognized, well, I can look at that. It's a test that their model did pretty well. So when given the actual aerosol from Pinatubo, as observed from space, when you put that into the Goddard climate model, the model produced this rapid cooling. It pretty much got the maximum surface cooling that we had actually observed in the real world. And importantly, it got this long goodbye. It got the recovery of temperature to pre-eruption levels pretty well. And you got to get a lot of physics right in order to get that recovery timescale right.
And yet, Hansen, using this fairly crude, decades-old model, made predictions that have, borne out, that have stood the test of time. And it's reason to take very seriously the predictions now that are being made with climate models that are actually far more sophisticated and detailed than the ones that Hansen used decades ago.
We are now in a climate system where the impact of his emissions is so strong, so clear, that nobody in the scientific community denies it. And when you get to that point in science, that's pretty strong. The real debate should really be about what are we going to do about this rather than talking about whether it's a climate change or not.